Hi students, all of you welcome. Welcome to Suneel Engineering Academy. I am Sunil Kumar Bandaru. Students, from today onwards, we are going to practice topic-wise MCQs in DC machine. This series will be very useful for your RRB JE, SSC JE or other state JE or AE examinations. Okay, so let us start the session. And about myself, I have 6 years of teaching experience in online platform and I have cleared many of written examinations like GATE, SAIL, Management Training, Prasar Bharati, BSNL JE and RRB JE. And you can also get previous videos in my YouTube channel Suneel Engineering Academy. Okay, and if you want PDF, you can download from suneelengineeringacademy.com. I will also give the link in the description. So let us start the session, guys. Coming to the first question. Armature core of DC machine is laminated to reduce the dash. Why we are laminating the armature core of a DC machine? So why we are going for lamination? To reduce the eddy current losses. To reduce eddy current losses. What are these eddy current losses? These are nothing but the losses due to circulating currents. Losses due to eddy currents. Eddy currents are nothing but circulating currents. Circulating currents. Okay, so these eddy currents are generally proportional to thickness of lamination whole square. Thickness of lamination square. If it is a more thickness, then more losses you will get. Okay, so that's why we have to reduce the thickness and to reduce the eddy current losses. Okay, so for example, why we are getting these eddy current losses or circulating currents? Whenever we have the area is wide cross section area. Okay, for example, a wide road we have. Whenever there is a wide road, then vehicles may be circulate. Okay, for example, area is very small, then that is the road is very small, then vehicles may not circulate. Okay, so in the same manner, if you can consider the core of the armature, if the area is more, then there is a circulating currents will be exist within the core. Due to this, we are getting the losses. Those are nothing but eddy current losses. So what we have to do in this case, we have to reduce the area. Okay, so for that purpose, we are going for lamination. That means like a book, we know very well about the book. Now in the book we have so many papers. So like that we have to take the laminations of the core and bunching all them together to form a single core. Why we are bunching all them to form a single core? To get the high mechanical strength. Okay, so whenever the area is reduces, then what will happen? Resistance is equal to rho L by A. As area is reduces, resistance will be increases. Okay, so as resistance will be increases means eddy currents will be decreases. Then eddy current losses are also decreases. Okay, Okay, so that means armature core of a DC machine is laminated to reduce eddy current losses. How these will be reduces? As area is reduces, then resistance will be increases, then the eddy currents will be decreases, so eddy current losses will be decreases. And this thickness of lamination, if the thickness of lamination is more or if the thickness of lamination is less, okay, then that means we use very thin, then eddy current losses will be reduced. Okay, this thickness generally we maintain approximately 0.5 mm. Okay, coming to the next question. DC machine laminated parts are armature and also dash. What are the parts are laminated in DC machine? Okay, so here armature is laminated. We have already discussed this one. Now coming to pole core, pole show, yoke and all the above. So what is the yoke? That is outer frame is nothing you can say yoke. In the pole is generally divided into two parts. One is pole core and one is pole show. So this pole show, this is the pole show, guys. Pole show. And this is the pole core. For that we are doing the winding. Okay, so this pole core is having already less cross section area. So less area in the sense already the eddy current losses are less. So it has the wide area it has a wide area, so there is a chances of eddy currents. So whenever there is eddy currents, we have to go for lamination. How to go for lamination. So the laminated parts are armature and also pole shoe. So we can write down the point. Pole core is no need to laminate. Pole core is no need to laminate, but pole shoe has to be laminate to reduce the eddy current losses. Okay. So here in the diagram you can get understand. Here this outer frame is nothing but you can say yoke. Okay, so this outer frame is nothing but you can say yoke. Here this is the part of pole shoe. Okay, and this is the pole core. Okay, so it has wider area, so it has to be laminated. In DC machine, iron losses occurs in which of the parts? Iron losses occurs in which part? Pole core, pole shoe, yoke, armature. Iron losses are nothing but hysteresis plus eddy current losses. Okay, so already we have discussed this eddy current losses are occurs in case of armature and also pole shoe. Armature core and also pole shoe. So that is 2 and 4. 2 and 4 is answer is option A. 2 and 4, so the answer is option A. Coming to the next question, guys. Approximate thickness of laminations of the DC machine is dash. Just now I have given. Okay, so what is the approximate thickness of lamination? Generally we are going for 0.5 mm. Generally we are going for 0.5 mm. Coming to the next question, guys. The armature of DC machine is preferably made with a dash. The armature of DC machine is preferably made with a dash. So armature, it has to be laminate. Okay, it has laminated armature core we are using, and to reduce the hysteresis losses also we are going for silicon steel. So if you add the silicon content, then it's a silicon steel X value is 1.6. Generally hysteresis losses is proportional to B max power X. X values are generally varies from 1.5 to 2.5. So varies for silicon steel, it is 1.6 means less. So that's why hysteresis losses are also will be reduced. Okay, hysteresis losses also will be reduced. So the answer is option C. Coming to the next question, guys. The commutator in a DC generator is act as dash. It is a very important question. It is a generator or motor, whatever it may be. In armature, always we have AC supply. Always we have AC supply. In armature conductors, we have AC supply. But DC generator means it has to generate the DC. It has to generate the DC. But how to convert AC to DC? For that conversion, we require one device, that is commutator. That is commutator. It converts AC to DC in case of generator. AC to DC. AC to DC means you can say it is a rectifier. Rectifier. It is mechanically operated, so mechanical rectifier. In case of motor, guys, in case of motor, here also in armature, always we require AC. But as the name itself, DC motor means we have to give the supply DC. But we require AC. Then here we require one commutator. This converts this DC to AC. Here it will be act as the inverter. So very important question. If they are asking DC generator, it is rectifier, DC motor, inverter. If they are asking DC machine, then either A or B. Okay. Coming to the next question. The commutator segments of DC machine made up of dash. It is a very important question and very repeated question, guys. Very important and very repeated question. Come on, try to give the answer for this. Here you are watching this video as recording now, so you have to just stop the video and make your answer, and after that check with my answer. Okay. So the commutator segments of DC machine made up of dash, that is nothing but hard drawn copper. Hard drawn copper. You can also attend my free live classes in Unacademy platform. You can open Unacademy app and select your goal as SSC, JEE and AE examination. Okay, and in that you will find out free live classes. In that you can get my free classes. Okay, coming to the next one, guys. In DC machine, the number of commutator segments dash. In DC machine, the number of commutator segments dash. Here the number of commutator segments always equal to number of coils. Number of coils. Okay. So if you are using more number of coils, then more commutator segments, then what is the advantage you will get? You will get more uniform waveform. More uniform waveform. That means ripple effect can be reduced. Ripple effect reduced. Very important question. This is also. So number of commutator segments is equal to number of coils. Coming to the next one, guys. How many segments will be there for the commutator of a 6-pole DC machine having a double layer winding armature with 72 slots? With 72 slots. Come on, try. Here we know very well number of commutator segments is equal to number of coils. In case of double layer winding, so if we have this is one slot 1, this is the slot 2. So double layer, this is the one layer, that is one coil. This is the another layer, that is the another coil. So coil 1, this is the coil 2. Okay, that is here number of slots are 2 and also coils are 2. So in the double layer winding, we can get idea number of coils is equal to number of slots. Okay, so here same double layer winding they have given. So now number of slots are they have given as 72. Now coils are 72. If the coils are 72, what about the segments? Commutator segments is equal to number of coils that is equal to 72. So the answer is option C now. So the answer is option. Okay, all of you clear? Coming to the next one. DC generators are designed to develop armature voltages not exceeding 650 volt because the limitations of dash. Because of the limitations of dash. Here DC generators are designed to develop armature voltages not. DC generators in the sense here in the armature always we have the AC. So that means we have to convert this one to a DC supply. Okay, so if you want to convert this AC to DC supply, here we require a mechanical rectifier, that is commutator. Okay, so the maximum voltage between the two segments is not exceeding than 50 volts. So whenever we are going to generate more voltages, there is a problem with the commutator. Okay, there is a problem with the commutator. Okay, so if you are going to induce the more voltages, then there is a sparking will be happen due to the reactance voltage. So that's why we have to limit this one for 650 volt because of the limitations of the commutator. But in case of AC generator, there is no commutator. And here we are using stationary armature. You can use stationary armature. So stationary armature means you can generate 11 kilovolts also. You can generate high voltages also. Okay, coming to the next one, guys. The teeth of armature of a DC machine are sometimes skewed. Skewed means we are making some angle. So this is a slot and this is the tooth. Okay, so this one is slot, this one is tooth or teeth. Okay, so it is generally, but in case we are going to make some skew, so we have to make the skew means we are making like this, we are making some angle. So due to this angle, then what will happen? The harmonics are reduced. Harmonics are the causes for vibrations and noise. So harmonics are reduced means reduce the vibration and noise. Vibration is reduced and noise is reduced. Okay, so the answer is option B. Okay, if you want to download the PDF, you can download from this website. Okay, so here first of all we have to read the question and try to make answer. Okay, after that check with my answer. Okay, so in a 6-pole DC machine, 90 degrees mechanical corresponding to dash electrical degrees. We know very well theta mechanical is fixed. Okay, theta mechanical is always fixed. Mechanical degrees 360 degrees now, and but theta electrical is depends upon the number of poles. The number of poles. Why? Because each pole create 180 degrees electrical. 180 degrees electrical. Okay, 180 degrees electrical. Here we have the relation between theta electrical is equal to P by 2 theta mechanical. P by 2 theta mechanical. So here number of poles are 6 and mechanical degrees they have given 90. So 2 3s, 3 into 90, 270 degrees. Very good. Coming to the next question, guys. The number of brushes required for 4 pole lap on DC machine is dash. All of you remember one thing. Always the number of brushes depends upon number of brushes depends on number of parallel path. Number of parallel path. Okay. So we know very well in case of lap winding and wave winding. Lap winding means overlapped in the nature. Okay. And wave winding in the wave type structure. Okay. Forwarding nature. Here it is the backwarding nature. Okay. So in the lap winding, always the number of parallel path is equal to number of poles. Okay. Number of poles. In case of simplex winding. So I am taking the example for simplex winding. Number of parallel path is equal to number of poles. Here number of parallel path is equal to always 2. Okay. And in case of duplex or triplex, it will be changes. Here the formula of A is equal to M into P. Here formula of the A is equal to 2 into M. M is equal to 1 for simplex, 2 for duplex, 3 for triplex. Okay, so here if they have not mentioned anything, then also we have to take simplex only. Okay, so here A is equal to P. So the number of brushes is equal to number of parallel path. In case of lap winding, number of brushes is equal to lap winding. Brushes is equal to number of parallel path, that is equal to number of poles. Here 4 parallel paths, so the 4 is the answer. And coming to the next one, 8 pole simplex lap winding will have dash parallel path. So just now I have given in case of lap winding, what is the formula? A is equal to MP. They have given simplex. So simplex in the sense A is equal to M is 1. M is equal to 1. A is equal to P, that is equal to 8. So the answer is option A. Coming to the next one, again they have given lap winding. So lap winding, whenever you see the lap winding, you have to make a formula. A is equal to MP. And it is a simplex or duplex. Here it is a duplex. Duplex means M is equal to 2. So then A is equal to 2P. So that is nothing but 2 into poles 8, that is equal to 16. So the answer is option B. All of you clear? So don't make in lap winding always A is equal to P. Here A is equal to MP. M value is depending upon simplex, duplex or triplex. Okay. Coming to the next question. Coming to the wave winding. Here in the wave, whenever we see the wave winding, we have to make the formula for the number of parallel path is equal to 2 into M. Here simplex given. Simplex means M is equal to 1. So the answer is A is equal to 2. Okay. So for simplex wave winding, the number of parallel paths are always 2. That is irrespective of the poles. Whatever the poles we have here, that is not a matter. So it is depends upon the parallel path only. Okay. And coming to the duplex wave winding. So again, whenever we see the wave winding, what we have to write the formula 2M. Here duplex. Duplex in the sense M is equal to 2. So that is A is equal to 2 into 2, 4. So the number of parallel paths are 4. So the answer is option B. Coming to the next question, guys. In a 12-pole triplex lap-wound DC armature, each conductor can carry a current of 100 amps. The rated current of this armature is dash ampere. Very good question. Okay, so the rated current of armature they are asking. We need to find out the rated current of armature. Here, which winding, guys? Lap winding. Whenever we see the lap winding, how many parallel path? A is equal to M into P. It is a triplex. M is equal to 3. A is equal to, that is 3P. Okay, that is 3 into poles are 12. That is 36 parallel path. Each conductor is considered as a one parallel path. One parallel path having 100 amps. Then 36 parallel path having 3600. That is nothing but 3600 amps. So the answer is option D. One parallel path 100 means if we have 36 parallel path, in the parallel means current will be added. Okay, so 3600. And which of the following represents the commutator pitch? Very important. Represent the commutator pitch. Here, coming to the first option, number of conductors spanned by one coil at back end. Back end in the sense it is the definition of back pitch. Back pitch. The number of conductors spanned by one coil at the front end of the armature, front pitch. Front pitch. The distance between the starting of first coil and its next successive coil. First coil and next successive coil, resultant pitch or winding pitch. Resultant pitch. And as the name itself, commutator pitch. The number of commutator segments between the two successive coils is the commutator pitch. As the name itself, we have the answer. Commutator pitch. So the answer is option D. Okay. And all of you remember one important thing here, the back end. Okay. Back end, back pitch, front end, front pitch. Okay. And the resultant pitch will give the starting of first coil to its next successive coil. Okay. Always this front pitch determines which type of winding it is. Determines winding nature. Front side, if you see the front side, then you can get the idea it is winding in the forwarded manner or in the loop manner. Okay, so that is loop manner means it is coming backward direction. So if it is the winding nature is backward, then you can say that is the lap. Only forward, you can say that is the wave winding. So like that you can get the idea it is a lap or wave winding by using the front pitch. And by using the back pitch will be determines the size of the coil. How much of size of the coil? Okay, size of the coil. These two are also very important. Coming to the next question here. The front pitch determines dash. Front pitch determines dash. Just now I said front pitch. It is the backward direction. You can say in the overlap. Overlap means lap winding. Okay. So if it is a forward direction, you can say is the wave type, wave man. So winding nature. Front pitch will determines the winding nature. Back pitch determines, just now I said, size of the coil. Here they are asking the question about progressive and retrogressive winding. The condition for the retrogressive winding. Here progressive manner is in the progressive nature. Progressive winding case. Here the relation between YB and YF. Progressive winding case, back pitch is more than the front pitch. In case of retrogressive, back pitch is less than that of the front pitch. Okay, so they are asking retrogressive, back pitch is less than the front pitch. So the answer is option C. And the answer is option C. Okay, if they are asking winding pitch, pitch, okay, or also resultant pitch. Resultant pitch. It will be different for lap winding and wave winding. So if it is a lap winding, it is in the backward direction. So that is you will get minus YB minus YF. YB minus YF. If it is in the wave manner, that is continuous. So we have to add YB to YF. So YB plus YF. This is the winding pitch. Okay. So here YB is less than YF. It is the retrogressive. YB is greater than YF. It is the progressive type. And winding pitch or resultant pitch for lap winding. Just now I have given for lap winding it is YB minus YF. If it is a wave, YB plus YF. Plus YF. So try yourself. After that check with the answer. Okay. So we know the back pitch is Z by P plus or minus 1. In the same way, front pitch is Z by P minus or plus 1. Okay. Minus or plus 1. So if you calculate this one, then you will get Z by P plus or minus 1, number of conductors by poles. So how many conductors we have? Two conductors for one slot. So one slot having two conductors. Total slots are 36 slots. So total conductors are nothing but 36 into 2, that is 72. Okay. So 72 conductors per pole plus or minus 1. So 18 plus or minus 1. That is nothing but 19 comma 17. Here if you calculate here also you will get same. 18 minus or plus 1, that is 17 comma 19. So here generally we will take back pitch is greater than the front pitch, 19 comma 17. So the answer is option C. So the answer is option C. Okay, coming to the next one. Commutator pitches of duplex and simplex lap winding. So let us take the formulas for lap winding and wave winding for commutator pitch. In case of commutator pitch is equal to plus or minus M. Here commutator pitch for wave winding is not depend upon the M, it is depend upon the average pitch. Okay, and we know very well M is equal to 1 for simplex, 2 for duplex. In this series it is the third time I am giving this. Okay, very important. Okay, 1 for simplex, 2 for duplex, 3 for triplex. Okay, so here YC is equal to, for simplex it is plus or minus 1. Okay, for duplex it is plus or minus 2. That means 2 and 1. Okay, they are asking for duplex it is 2, simplex it is 1. So the answer is 2 and 1. So option B. Okay, coming to the next question guys. In a lap winding DC machine, number of conductors are 100 and number of parallel paths are 10. Find out the average pitch. Find out the average pitch. Very easy question. The average pitch in lap winding is nothing but back pitch plus front pitch by 2. Okay, by 2. It is equal to pole pitch. It's equal to nothing but pole pitch. Pole pitch is nothing but number of conductors per pole, Z by P. So Z by P is nothing but number of conductors are 100 and number of poles. They have not given the poles, but in lap winding A is equal to P. In lap winding A is equal to P. So that is nothing but we can say parallel paths are 10. Our poles are 10, that is equal to 10. So the average pitch is nothing but 10 you will get. So the answer is option C. Okay. Now coming to the next question guys. In single layer winding, the number of coils equal to dash. In single layer winding, the number of coils equal to dash. And if you want to get the full data for this lap winding and wave winding with the commutator pitch, average pitch, okay, front pitch, back pitch relations, you can download the PDF from suneelengineeringacademy.com. In that I have given along with MCQs, I have given the data of those. Okay. And coming to the next question, in the single layer winding, the number of coils equal to dash. So this type of questions are very important. Let us take a small concept about single layer and double layer. So as the name itself, we have the matter single layer, double layer. Okay, it has only one layer, it has two layers. Okay, for example, I am taking this is the one slot or one pillar of the house. Okay, now slot 1, slot 2. Okay, so it is, we can compare this slot is like a pillar of the house. Okay, pillar of the house. Coil is nothing but first floor one coil, second floor two coils, like that. Okay, it is the number of houses. Number of coils are nothing but number of houses. Okay, so here in the single layer is nothing but it has only one layer of the coil. So only one house. Let us take the coil 1 only. Now coming to the double layer winding, let us take same those two pillars, that is a slot 1, slot 2. Here double layer, that is two layers, two houses or two coils. It is two supporters only. We have the two houses or two coils. Okay, so here coil 1, coil 2. Okay, from this one, what you can get idea? Here in the double layer winding, you got coils are 2, and also slots are 2. So number of coils is equal to number of slots, that is equal to 2. So same equal relation in the double layer winding. But coming to the single layer winding, slots, number of slots are 2, but coils only 1. So if you want coils, you have to divide it by the slots. So number of coils is equal to number of slots by 2. So 2 by 2 is equal to 1, you are getting coils. Okay, that is half of the slots. Half of slots. Okay, in the double layer winding only, slots and coils are equal. But in case of single layer winding, 2 slots, 1 coil. Coils are less. So whenever the coils is equal to half of the slots, coils are less. Okay, I think all of you clear about the single layer winding and double layer winding. Coming to the next question. Which of the following windings are used in all DC machines? Which of the following windings are used in all DC machines? In the DC machine, harmonics effect are less. Okay, so that's why we go for closed winding. Open winding in case of AC machine, mainly to reduce harmonics. Okay, coming to the next one, DC machine windings are dash. DC machines windings are always full pitch to get more EMF. In case of AC machine, we go with a short pitch winding to reduce the dominant harmonics. Lap winding is preferred for dash. Here, these are very repeated questions. Lap winding and wave winding preference. Lap winding. So, for example, let us take number of poles are 8. Here also poles are 8. Okay, number of poles are 8. So here number of parallel path is equal to number of poles, that is 8 parallel path. So 1, 2, 3, 4, 5, 6, 7, 8. So if you have 8 parallel path, then what is your total current? So sum of all this. So there is a chance of high current. So we can easily get the high current, and each parallel path can contain less current only, but total current will be high. So we can get maximum current from this lap winding. So it is preferred for high current application. High current. And for the same power rating, if you have high current, if you go with less voltage also enough. So high current, low voltage applications. Low voltage applications. And in case of wave winding, the number of parallel path always 2 only. So here when number of the parallel paths are 2 only, in the sense you can get less current. Okay, we can carry the less current only. So that's why we go with the high voltage. So high voltage and low current application. Okay, low current application. So lap winding they are asking high current and low voltage. So the answer is option A. Coming to the next question, guys. Here they are asking wave winding. Wave winding, low current. So if low current, we can go with the high voltage. low current, high voltage, low current. So here also the answer is option A only. Okay. Coming to the next one. In lap winding, the DC generator having poles are P and number of conductors are Z, then number of equalizer rings. What are these equalizer rings? In case of lap winding, number of parallel paths are more, that is equal to poles. Okay, that is equal to poles. So to equalize this, to equalize the currents, we use or we require equalizer rings. Equalizer rings. Okay, this number of equalizer rings are nothing but 2 into conductors by poles. As a 2 into conductors by poles. So the answer is nothing but 2Z by P. In case of wave winding, guys, only A is equal to 2 parallel paths only. So current divided equally. So no need of equalizer rings. No need of equalizer rings. Okay, so if they are asking the equalizer rings for this one is nothing but 0. In lap winding, we require 2Z by P. We require 2Z by P. Okay. Coming to the next one. In a 4-pole lap winding DC machine, the resistance of one conductor is 2 ohms and the total number of conductors are 100. Then what is the total resistance? What is the total resistance? Generally, we have the formula for the lap winding to find out the total resistance. That is nothing but resistance of one conductor into number of conductors by A into P or A square or P square. A into P or A square or P square, that is A square. If you take resistance of one conductor 2 ohm, number of conductors is 100 by parallel path square, that is P square or A square, 4 square. Okay, so that means you will get 200 by 16, that is nothing but 12.5 ohms you are getting. So this is the one method. And coming to the second method, just understanding. 4-pole lap winding having 4 parallel paths. Resistance of one conductor is 2 ohms and the total conductors are 100. So if the total conductors are 100, then we have 4 parallel path means each parallel path having 25 numbers, 25 conductors. Okay, each one having 2 ohms, like that. Each one having 25, like that we have 4 parallel paths. Okay, so 25 conductors having each one is 2 ohms, and what is the total resistance? 25 into 2, 50 ohms. Here also 50 ohms. Here also 50 ohms. Here also 50 ohms. So all are in the parallel. Then what is the total resistance? 50 by 4, that is 12.5. Sorry. 12.5. Okay, so you can use any of the method. And coming to the next one, the number of equalizer rings used in 4-pole wave winding. Just now I have given in wave winding equalizer rings not required. Rings not required. So that means here if they have given number, that is not correct. So the answer is option D, none. And D, none. Okay. Okay, student. Dummy coils in a DC generator is provided. Dummy coils. Dummy coils we are using in case of wave winding. Why? Because why we are using in wave winding? Because in wave winding the number of parallel paths are 2, that is very less. So with less number of parallel path, the conductors may not divided equally throughout the machine. So whenever it is rotating, it is mechanically unbalanced. Mechanically unbalanced. So to balance the rotor, okay, to provide mechanical balance to rotor. Mechanical balance to rotor. To rotor or armature. We are using this dummy coils. Okay, in case of lap winding, dummy coils are not at all required. Lap winding not required. Dummy coils are not required. Okay, so here to provide the mechanical balance to the rotor. Coming to the next question, DC generator. In DC generators, brushes are used for dash. So what is the purpose of the brush? Brushes are nothing but to collect the current. To collect the current with a minimum sparking. With a minimum sparking. We can use copper brushes, carbon brushes, and also some metal graphite like copper graphite. Okay, so our that somewhat of alloys also can use. Okay, carbon brushes having so many advantages. Coming to the next one. So in case of DC machine, the brush contact drop is assumed to be for dash for carbon brushes. Okay, for carbon brushes. So if you can consider carbon brushes, so generally we can consider for pail. If you use the carbon brushes, generally we take 2 volt is the brush drop. Okay, irrespective of the number of brushes. If you can consider metal graphite, okay, metal graphite. In the metal graphite, metal having high conductivity, so less voltage drop, it may be 0.5 volts. Okay, 0.5 volts. So this metal graphite, these are using in case of high ratings. In case of high ratings, these are used in case of normal ratings. Okay, so here answer is option D. Coming to the next one, which of the following is correct? The following type operation, their applications are correct. Carbon brushes, just now I said it is used for normal rating, correct only. Electrographite, large ratings. Okay, copper graphite, it is also used for high current density. So all are correct, so can you the answer as option D. Coming to the next one, which are the following are advantages of carbon brushes over the copper brushes? Advantage of carbon brushes. Carbon is a non-metal. Non-metal in the sense it is somewhat of smooth than metal. Okay, so they are not hard as copper brush. Yes, correct. They are self-lubricating. So smooth means they are also self-lubricating. In case of any sparking, they will be less damaged than the copper brushes. Yes. In case of any sparking, they will be less damaged. Why? Because their operating temperature is more. It means carbon high operating temperature. So all are correct. So the answer is option B. Coming to the next question. Next questions are belongs to EMF equation. Okay, EMF equation. These questions are also very important, guys. The EMF induced in the DC generator armature winding. In armature winding is the DC generator or DC motor, whatever it may be. In case of armature winding, we have AC supply only. Have AC supply only. So the answer is option A. Okay, answer is option. We have the commutator that will be converts AC to DC or DC to AC. A 4-pole generator having lap wound armature winding has 51 slots. Each slot contains 20 conductors. What will be the voltage generated in the machine when driven at 15,000 RPM? Assuming flux per pole is 7 milliweber. Okay. So in case of this EMF generated or voltage generated case, we know the formula. In that formula also very important, we have to check it is which type of winding and also the number of conductors. E is equal to 5Pn by 60 into Z by A. Remember here the very important is type of winding. lap or wave. So we have to concentrate on this. Second point, number of conductors. Okay. So here flux 7 milliweber, 7 into 10 power minus 3. Number of poles, 4 pole generator. Speed 1500 rpm by 60 into number of conductors. It has 51 slot, but each slot contains 20 conductors. So total conductors are 51 into 20 by A. Here which type of winding? Lap winding. Lap winding in the sense A is equal to P. That is also nothing but 4. This one is cancelled out. Okay, this one is cancelled. 61s, 62s, that is there 5. Okay. Here consider it is 51 into 20 approximately 1000. This 1000 is 10 power minus 3 almost cancel. 25 into 7 175, very near to the 175. Answer is option 4. Answer is option 4. Okay, like that we have to just to go with approximation, and here very important lap winding or wave winding, and second one number of conductors. Generally the students confused in these two only. Coming to the next one, an 8-pole DC generator has simple wave wound armature containing 32 coils of 6 turns each. Its flux per pole is 0.06 Weber. The machine is running at 250 rpm. The induced armature voltage is dash. What is the induced armature voltage? That is nothing but EMF. Same 5 Pn by 60 into Z by A. Okay. So here it is the first one, wave winding. So A is equal to 2. Flux 0.06 poles, 8 poles, speed 250 by 60 into Z number of conductors. Here how many conductors? Here it has 32 coils of 6 tons each. So total number of tons, 32 coils of 6 tons each. 32 into 6. Then total number of conductor, each ton having 2 conductors. So then 32 into 6 into 2. So 32 into 6 into 2 is the number of conductors. A is equal to 2. Okay. A is equal to 2. So come on, calculate here. 25 into 8 is 200. Okay. This 0 and this 2 zeros is cancelled out. 6 into 20 is 120. 120 means 6 1 6 2. This 2 is cancelled out. Then 32 into 6 into 2. 6 into 2 12. 32 into 12, that is approximately 300 something. So the answer is option B. So the answer is option B. Okay. Like that, you can simply calculate the EMF equation. The very important, which type of winding? Second one, number of, that is finding the conductors. Okay. Okay, students, we will discuss the remaining in the next session. And if you want to download the PDF, you can download from suneengineeringacademy.com. I will give the link in the description box.